Hello, everyone, and happy Earth Day, and welcome to the Natural Areas Association special virtual symposium in celebration of Earth Day 2021. I'm Maura McGinty-Kloss, and I am NAA's Programs and Communications Manager, and I'm delighted that you are joining us for Nature's Firefighters, the role of beaver in wildfire mitigation and recovery. However, before I get started, I'd like to talk to you a little bit about the NAA. The Natural Areas Association is a nonprofit member organization dedicated to the support and advancement of natural areas professionals who protect biodiversity through science-based conservation, stewardship, and advocacy. NAA is a community that identifies challenges, develops solutions, shares critical findings, and advances practices in conservation, preservation, and restoration of nature through networking and collaboration. For over 40 years, we've been doing this with our peer National Areas Journal, which is a peer-reviewed publication that comes out 4 times a year. And I invite you to look for our April 2020 issue that's coming out anytime now. Stewardship and Action, which are in-person field workshops as much as they can be with COVID. State Natural Areas programs, which are being held virtually right now and are, again, peer-to-peer support for people who manage land managers in state natural areas. The Natural Areas Conference, which we hold every fall. The Science Advisory Committee, which is a dedicated group of esteemed and respected scientists who are helping the NAA and our members to stay ahead of approaching issues. And we also host a monthly webinar series. If you're not a member of the NAA, I invite you to consider joining. Individual memberships are only $79 a month. That would include free access to all of our monthly webinars that are held the 3rd Tuesday of every month, a digital subscription to the Natural Areas Journal, special discounts to events and conferences like this one, access to the NAA online member portal, and complimentary invitations to the NAA State Natural Areas Roundtables. So let's get started. Now, NAA first explored the topic of beavers and why they matter when Ben Goldfarb gave a keynote presentation called Eager, based on his book, Eager, The Surprising Secret Life of Beavers and Why They Matter, during the 2020 Natural Areas Virtual Conference in October. This presentation was easily ranked one of the most popular presentations during the event, and it seemed like a perfect topic to celebrate Earth Day. We were so excited when Ben and his esteemed colleagues were able to join us. Unique to this symposium is that we will not only hear from beaver and low-tech restoration experts, but we are also fortunate to have someone who is highly respected in the world of fire management, who will open our event today and will add her perspectives to the discussion. If you have any questions during the symposium, please post them in chat. I'll be helping Ben to monitor chat and capturing the questions so that we can include them in the discussion at the end. So now let me introduce our first speaker. I'm honored to introduce our first presenter today, Lenya Quinn-Davidson. Lenya was also a plenary speaker during the 2020 Natural Areas Virtual Conference in October. And it was through this event that she became more fully aware of the role of beavers in wildfire mitigation and recovery. Lenya is an area fire advisor for the University of California Cooperative Extension in North Coast of California and the director of the Northern California Prescribed Fire Council. Her primary focus is on the human connection with fire and increasing the use of prescribed fire, sorry, that tripped over that, fire for habitat restoration, invasive species control, ecosystem, and community resiliency. Lenya works on prescribed fire issues at various scales, including locally in Humboldt County, where she engages private landowners to bring fire back as a land management tool, and at the state level, where she collaborates on policy and research related to prescribed fire, and nationally through her work on prescribed fire training exchanges. She's passionate about using prescribed fire to inspire and empower people, from rural ranchers to agency leaders and to young women pursuing careers in fire management. So Lenya, I welcome you, and I invite you to kick off our talk today. Thank you.
It is such an honor to be here. Thank you so much for the wonderful introduction and for having me as part of this symposium today. I have to say, when I was asked to join this symposium, I felt a little embarrassed because I am by no means a beaver expert. I don't work on beavers at all, but I am a fire person, and I'm really excited to start the symposium with some framing around fire and some perspective, and helping us think a little bit about the parallels between beavers and fire. And I'll start by picking on the title of the symposium a little bit, because I really don't think about beavers as firefighters as much as I think of them as really analogous to fire, as being some of the most impactful processes in North America and things that we can learn from and that we need to learn to adapt and live with. And this really came to my attention last fall when Ben and I were plenary speakers together for the conference. And I was actually in the middle of reading his book when we were introduced and when we served on that plenary together. And it was so striking to me that in Ben's book, you could actually take and substitute the word beaver with fire, and it would almost work. The histories are so similar. The issues are so similar. The treatment of beavers and the treatment of fire and the people who have used fire, there are so many parallels there. And I was actually so inspired that I write a regular fire science blog, and I ended up writing it last fall on beavers and saying if fire were an animal, I would actually say that fire would be a beaver because there are so many connections and so many parallels. So I hope with today's talk to kind of shed some light on some of those parallels, really through a fire perspective. I won't be talking about beavers very much. I want to share some of my work and some of my thoughts on fire and kind of looking into the future of how we can live with fire, how we can start accepting some of these processes and learning to maximize the benefits from them and be resilient in the face of them. So I'm going to focus a little bit on scale and thinking about the scale of fire and some of the issues that we're seeing there and some of the history, some of the interconnectedness that we see with fires that we also see in the beaver world, and that I think we'll hear from some of our other speakers today on all of these things. And then also on adaptation and how that's really the future that we have in front of us, especially with the changing climate. Fire's not going away, and how can we learn to live with it? And what are some of the tools and strategies that we have to have that perspective? So let's start thinking about scale. Now, I don't know how many of you are fire people and are familiar with fire regimes in the United States pre-European settlement, but I really like this figure. This comes from Landfire, and this is a map of historical fire regimes across the United States. The main takeaway here, I love this because it's so colorful and it shows the diversity, but it also shows how much fire was on the landscape pre-European settlement. If you look at that red and the pink areas, those are areas that were burning at least every 35 years. A lot of those areas, especially the pink, sometimes on a frequency of every 2 to 5 years. There was so much fire on the landscape pre-European settlement. Fire was a hugely important process and force for shaping the landscape, for shaping the plant communities, the animal communities. And, based on this Landfire estimate, 43% of the United States was burning at a pretty high frequency. Now in California, that's true to an even higher extent. And actually, if we look back at that, you can see that most of California, where I live, is pink. So it was burning very frequently at low to moderate severity. And most of our beloved landscapes and habitats in California have a really strong connection to fire. And an important fire story that often includes human ignitions and human use of fire. So these are some examples of some of our most beloved ecosystems in California that are fire adapted. Stephen Pine, who's a pretty well-known fire historian, recently wrote in a book about California and fire that 54% of our habitats in California are actually fire dependent, meaning that they need fire in order to persist. Most of the rest of our ecosystems in California are fire adapted, meaning that they've evolved to survive fire. So fire is just a huge part of our landscape. And every time that I look around, I see fire on the landscape. I see how it shaped it. I see where it's missing. That's kind of the lens that I view my whole surroundings with. But it's interesting because I think the conversation around fire has gotten a little confusing. We're always talking about how catastrophic they are, how big the fires are, how unprecedented it is that they're burning, these huge fires. 5 of California's biggest recorded fires on history happened last year in 2020. We had our first fire that was over 1 million acres in California. it's hard not to be overwhelmed and to think that fire is coming back with a vengeance, that there's more of it than there's ever been. We see these quotes in the media that are implying that that there's never been this much fire. That the West is seeing fire on a scale that is totally out of the norm. And while I agree that patterns of fire size and severity are unprecedented, the area burned is not. And pre-European settlement, researchers estimate that in California alone, we had more than 4.5 million acres burn every year. And a lot of that was, from lightning ignitions, but also from the human use of fire. For thousands and thousands of years, people were using fire on a massive scale in California and across much of North America, as we saw on that fire regime map. Last year in California, which was noted as an unprecedented fire year, we had about 4.2 million acres burn. So it still wasn't even commensurate with what we knew to be true for before European settlement. So when I was reading Ben's book, I was very struck by the scale of the influence that beavers also had. And he says in his book that beavers once submerged 234,000 square miles of North America, an area larger than Nevada and Arizona put together. So if I close my eyes and picture that time period where fire regimes were fully intact and beaver populations were fully intact, and these two processes, I'm calling beavers a process, even though I know they're an animal, these two processes fully intact and active on the landscape, and all of the amazing complexity and biodiversity associated with that, it's a different landscape than we have now. And it's so interesting to think about how powerful those two forces were and how much we were able to take them away. And so I was also struck by some of the terms that we use to talk about the history of beavers are the same as those that we use to talk about fire. So suppression, exclusion, eradication, extirpation, these are the same words that we use in fire, that we use to talk about the beavers, also to talk about the people and the communities who used fire and who put fire on the landscape. There is such a rich history around people and management of all of these things. And so I see such strong parallels there. I think it's really compelling to think about. And to think about how much is lost when we take these processes away. And so when we remove these things, when we suppress them and exclude them and eradicate them, what else is lost? I think there's so much that we don't even know and understand. I share this picture because here in the north coast of California, I do a lot of work in our deciduous oak woodlands. And these woodlands are some of the most biodiverse habitats in the Pacific West. And they're being lost to large extent because of conifer encroachment and forest densification due to a lack of fire. These deciduous oak woodlands were maintained for millennia with active fire, both lightning ignitions and human use of fire, and they're hugely important. And I like this photo because it shows the lupin in the bald hills of Redwood National Park. And these lupin blooms are known to occur 2 years after prescribed fire. So these oak woodlands are intact, mostly because people have continued to use fire in them and to keep those conifers at bay. And people actually time their visits to the park to take advantage of these lupin blooms, knowing that they were burned 2 years previous. So it's just kind of an interesting connection to prescribed fire. But we also have more serious work that we do looking at oak woodlands and the benefits they provide. And I'm leading a study right now looking at conifer encroachment and the water demands of the in the absence of fire. This is kind of the progression that we see with these young conifers coming up under the oaks in a matter of decades, overtopping them and causing mortality. But one of the things that we don't always think about with fire is that if we've taken fire off the landscape and this kind of process has happened, how much water is being lost to all of that tree growth into these dense forests? So we know from other areas, our study's still in progress, but we know from similar studies in other areas that the more good fire we have on the landscape, the more water we will have in streams and creeks. So these connections are strong. And we see those same kinds of connections when we talk about beavers. And all the different benefits they provide and all the different ways that they're connected to the world around them. Fire is exactly the same. And we use fire in the prescribed fire world to meet a whole host of objectives, whether it's habitat restoration or invasive species control or cultural burning and cultural reasons. There are just a multitude of reasons why we are connected to fire and the beavers. I also thought it was compelling in Ben's book. He talks a lot about the different people who are working on these issues around beavers and the beaver believers. And we have a parallel thing in fire and in prescribed fire, where the people who work on prescribed fire are some of the most passionate and compelling people that I know. And that's partly why I love doing the work that I do. But we're able to pull the most diverse coalitions together around prescribed fire because fire touches down in so many different ways in people's lives. So this photo collage shows a lot of the people that I work with in fire, including Native American tribes, ranchers, my son there in the upper right, out on a burn, community members. It's really interesting to see how diverse the supporters are of prescribed fire and how fire can actually bring those often disparate groups together. So right now I'm working on some legislation here in California that would promote prescribed fire and help ease liability concerns. And the coalition we pulled together to support this bill is tribes, the California Cattlemen's Association, and groups like Defenders of Wildlife. And how often is it that you see those groups working together to support one single issue? It's really impressive. And so I really liked seeing in Ben's book that the same kinds of coalitions are coming together around these beaver issues. It's really powerful when you can pull those kinds of different types of people together and find their shared passion. Now, adaptation, I think I'm going to start wrapping up here, just talking about adaptation, because that's another theme I think we're hearing a lot around the beaver issue, and certainly in fire, it's our main thought right now. Fire is not going away. We're going to continue to have wildfires. We're going to have bad fire seasons. This fire season's looking like it's going to be really intense. We're in a severe drought in the West right now and in California. And so how can we learn to live with fire? And what are the things that we can do to really understand that we're part of the system, fire is part of the system, and we need to live together? So in the fire world, there's a real focus right now on fire adapted communities and all the different ways that we can adapt to fire. It's not just about fuels treatments. It's about regulations and policy and community planning and how do we build our homes? Can we build our homes to actually withstand fire better? How do we set our communities up so that they are able to evacuate in the case of fire, but that they're also able to recover after fire? How can we be more resilient as a society in the face of fire, much the way that we deal with earthquakes and hurricanes? How can we set ourselves up so that we can actually survive and even thrive in a world that still has fire? I focus a lot on the reintroduction of fire and using fire as a tool. I think this is really where my passion is bringing fire back as a process and reconnecting people with fire and reclaiming the values and the potential of fire to be a positive force on the landscape. So I work on this in the policy realm, research, training people, and really empowering communities and agency leaders and tribes to all bring this back and really work toward a future where fire is part of the landscape and part of our human process. So with that, I would like to close. I'm really excited to hear from our other speakers and to understand all the work that they're doing and how some of these analogous issues are in the beaver world. So I hope the fire framing was useful. And I will be turning it over to Ben, and I have the honor of introducing him. I was really excited to meet him last year and to read his book. I don't know how many of you have read Ben's book, but he is such a wonderful science writer. And if you haven't read it, I highly recommend picking it up. It's no surprise that he's an award-winning author and science writer and that his journalism has appeared all over the place, including in Science, in National Geographic, and in the High Country News. And he's been identified as, one of the best science writers out there. So in our time, his next book, it sounds like he's got a book coming out in 2022 on road ecology. And he also writes a bunch of wonderful shorter pieces. I just read one that he put out this week on microfishing, which I thought was really interesting. So Ben, thank you so much for inspiring me and helping me see some of these connections. And I can't wait to hear your talk.
Wonderful. Thank you so much, Lenya, for that warm introduction and for that wonderful series of parallels that you drew that were so apt. Yeah, I think maybe this symposium should be called Nature's Firefighters and the Animal Kingdom's Fire Analogs, because that you hit the nail on the head with that talk, I think. So our next three speakers who follow me will be really diving deep into the ways that beavers and wildfire interact. But I just wanted to begin for my part by talking a bit about beavers themselves and providing sort of the fundamentals of beaver ecology, history, and sort of ecological work. What do beavers do on the landscape, and how have we arrived at this moment in history where we're beginning to recognize their really important role in interacting with wildfire? So to begin with, of course, beavers are rodents. They're North America's largest rodent. Typical fully grown beaver is, somewhere in the 40 to 50 pound range. So they're pretty hefty animals. And of course, they're semi-aquatic rodents, so they spend all of their lives in and around water. They're also entirely herbivorous. Their primary food source is the cambium of trees. That's the inner bark of trees. Out here in the West where I live, aspen, cottonwood, willow are kind of the big three beaver food sources, but they'll take just about any deciduous tree. They do tend to avoid conifers, and they eat lots of, green herbaceous vegetation as well. So of course, in addition to cutting down trees to eat the cambium, the inner bark, they're also using the wood as construction material. There are two basic types of beaver structures. Of course, first is the lodge, which is sort of the fundamental beaver housing unit. In the lodge, you've got, typically two to as many as 8 or so beavers. There are usually 3 kind of year classes of offspring: the newborn kits, the babies, the 1-year-olds and the 2-year-olds, along with the mating male and female, who are all sort of cohabitating. And then those 2-year-olds will sort of disperse out, like teenagers heading off for college. And then, of course, in addition to the lodge, the other iconic beaver structure that I'm sure you've all seen at some point is the beaver dam. Dams play sort of multiple functions in beavers' lives, but the primary idea is it's a security feature, right? A beaver on land is sort of this, fat, slow, smelly, waddling package of meat. And by building that dam and creating this impoundment, they're basically expanding the extent of their own aquatic habitat, right? Beavers are very agile, powerful swimmers, much safer in water than on land. So, they're just creating their own habitat by building these structures. Typical beaver colony is building, in some cases, more than a dozen dams. There's usually one sort of large primary dam, and then a number of smaller secondary dams. This is, of course, not a typical beaver dam. This is in Voyageurs National Park in Minnesota, but is a kind of a cool indication of what they're capable of when left to their own devices for many decades. So some of these structures can really be quite massive on the landscape, and create correspondingly massive impoundments. Here's a beaver pond and wetland complex that's probably 250 to 300 acres and is the creation of a single strategically placed beaver dam. I'm always very impressed by their hydrological savvy. I feel like if you told an Army Corps engineer to build a dam that would minimize labor and maximize impoundment, they would choose the same spot as the beaver did. The other really important beaver feature that certainly influences how water moves across the landscape is that they dig these elaborate canal networks. networks. They're really powerful excavators as well as being great builders. And again, the point there is, you dig a canal up into the forest, and then you can float your aspen back down the canal rather than having to drag it overland. And these canals can extend hundreds of meters up into the forest, and are really important in terms of sort of moving water across the landscapes. They're great diggers as well as builders. And then you kind of put it all together, and here's a kind of an archetypal beaver complex. This is at about 11,000 feet in Colorado, so they really get way the heck up there. And here, of course, you can see that the stream is sort of winding along through the valley, and then it hits all of these linear features here, these beaver dams, which are collectively holding, certainly hundreds of thousands of gallons of water and probably millions in this little valley here, and really modifying geomorphology and the kind of the stream's extent at a pretty massive scale. I think the other really important point too, and Lenya talked about this in her talk about how fire, of course, is a process that creates these different successional stages. And beavers do the exact same thing. The beaver complexes are not static; they're constantly evolving. Here's a kind of a nice illustration of this, also in Minnesota. You can sort of see in the background here is the former beaver dam. The beavers abandoned the area. The dam broke down. The pond drained. And you're left with this, lush, wet meadow, which ends up being wonderful forage for moose and deer and good bird habitat. And in this case, actually, the lodge was sort of left behind, and a pack of wolves actually moved into this lodge and raised their pups in that lodge. So, the point is that beavers create these cycles, right? A beaver complex moves from pond to wetland to wet meadow to forest, and back to pond as beavers come and go over the course of many years. And that dynamism, that succession is a really important part of the beaver process, and is one of the things that makes them so analogous to wildfire, as Lenya pointed out. So historically, we don't know exactly how many beavers lived in North America, but there's no question that their influence was quite vast. The best sort of pre-European arrival population estimate we have is, as many as 400 million beavers. There were, of course, those hundreds of millions of beavers would have created hundreds of millions of beaver ponds on the landscape. And as Lenya pointed out, this is my sort of very back of the envelope math. But perhaps 235,000 or so square miles were impounded by beavers, which is quite the vast area, and we can get a sense of their ecological import historically by considering Native American tradition and sort of traditional ecology. In the American West, many native tribes actually didn't participate in the fur trade, didn't kill beavers because they had cultural prohibitions on beaver killing. And the reason for that, of course, is they understood how important beavers were in creating these ecological oases in these otherwise kind of arid Western landscapes. Tribes like the Blackfeet, again, considered beavers deities and had cultural prohibitions against killing them. So I think that's one very important thing, of course, is that today we're talking about working with beavers to achieve ecological goals, but this notion that this is an important animal that modifies the environment at a vast scale, certainly not original to Western science. When the first European colonists and explorers and farmers and trappers arrived, they were sort of universally gobsmacked by the extent of beaver influence. Lewis, of course, of Lewis and Clark fame, described seeing beaver dams in every single tributary of the Missouri Basin, as far as the eye could see up into the mountains. You read sort of similar accounts from all kinds of different early white travelers. So no question, this animal was ubiquitous and modified the landscape at a vast scale in some really ecologically beneficial ways. Unfortunately, the beaver's heyday would soon come to a kind of a catastrophic end. The industrial fur trade begins in New England in the early 1600s or so, very quickly spreads west and south across the continent. And by the 1840s, beavers are pretty much functionally extinct in the lower 48. They're down to around 100,000 beavers or so at kind of the nadir of the population, nearly all of them in Canada. And it's really hard to overstate the extent to which the industrial fur trade was this kind of driver of early American history. Beavers, along with timber and cod, were really the most important resources that the colonists found in the quote unquote New World. And practically every significant historical event prior to the Civil War has some kind of intimate beaver connection. The Louisiana Purchase, for example, one of Jefferson's motivations was securing new trapping grounds. Here's kind of a nice indication, I think, of how deeply embedded beavers were in early American economies. This is a beaver coin minted by the Oregon Territory, which covered pretty much all of the Pacific Northwest. And the value of one beaver coin was fixed to the value of one beaver pelt. So the entire economy of the Northwest operated on the pelt standard. In addition to being a hugely significant historical event, the fur trade was also a profound ecological and environmental event. We don't really think about fur trapping in the same terms as we think about, the deforestation of New England or the busting of the Midwestern prairie or gold mining in the Sierra Nevada as being kind of this seminal environmental disaster that shaped North America. But there's no question that it was. I mean, what happens when you, kill hundreds of millions of beavers? Well, hundreds of millions of beaver dams break down, and hundreds of millions of ponds and wetlands drain. In the Long Island Sound, so much nutrients flowed out of beaver ponds that it fertilized this huge plankton bloom. So today, if you took a sediment core on the ocean floor in New England, you would find a kind of a layer of diatoms that were fertilized by the beaver bust. I think that's kind of an incredible indication of how geological this event truly was. And of course, it shaped aquatic systems and wetlands and wet meadows in really profound ways too. In a healthy beaver-rich stream, all of those beaver dams are acting as speed bumps, slowing water down and spreading it out across the floodplain. And when you lose beavers, there's really nothing checking the velocity of water. And you often get this kind of really dramatic and catastrophic incision and the disconnection of streams from their floodplains. I think that we often see this kind of degraded stream and associate it with cattle grazing or mining or some other historical environmental impact. But in many cases, this kind of degradation really began with the fur trade. And of course, the loss of that floodplain connectivity would have been a catastrophic form of habitat loss for all kinds of species. What did it mean for moose or mergansers or boreal toads that they lost all this beaver created habitat? We'll never fully know, but there's no question that it was truly disastrous. Kind of the poster species for the importance of beavers and for the significance of losing beavers is coho salmon. And in the Olympic Peninsula in Washington, there have been estimates that that coho lost something like 97% of their winter rearing habitat, in part due to the loss of beavers. So, there's no question that beaver trapping was a profound environmental disaster in many ways for many species. So fortunately, by 1900 or so, we start to wise up, and all of these different game agencies around the country start to reintroduce beavers to recognize that this is actually, a pretty useful critter. And as beavers recover throughout the 20th century, aided by reintroductions and trapping restrictions, they begin to increasingly come into conflict with humans. This is sort of the second phase of the beaver story. In the first phase, they're this commodity that's persecuted for their pelts, and in the second phase, they're this recovering species that has become a nuisance because, of course, in the absence of beavers, we colonized all of the low gradient streams and floodplains where beavers like to build dams. And as beavers return to their former environment, they find that we've basically occupied it. And this is the sort of conflict that can emerge. Here's a sort of a flooded cabin in New Mexico that I visited a few years ago. And here you can sort of see, the beavers begin their dam in the left-hand corner of the screen, dam up to the base of the cabin, then incorporate the cabin in their dam, and then continue on the other side. So, you wouldn't want to be that landowner, but you have to admire the ingenuity of the beavers in this instance. Of course, the way that these sorts of beaver conflict are generally handled is by trapping out the offending beaver. Um, every year, federal and private trappers take certainly many tens, if not hundreds of thousands of beavers. We don't know the exact number, which makes a certain amount of intuitive sense. Of course, the beaver's causing a problem, get the beaver out of there. But is obviously ecologically sort of nonsensical, because we know how important these animals are in a lot of ways for a lot of reasons. And in response to the kind of the long-term persecution of beavers, we've sort of entered what I think is the third phase of beaver-human relations. If the first was persecuting for their pelts, if the second was considering this nuisance species, the third is that there's really this growing movement of ecologists, hydrologists, geomorphologists, farmers and ranchers, concerned citizens, who recognize that, hey, these are some pretty important animals, which we, should be trying to live with, rather than reflexively killing them whenever they cause any kind of conflict. This third phase of beaver-human armistice has a few different components. I mean, there's an increasing emphasis on coexistence, through the use of beaver deceivers and flow devices, these kinds of pipe and fence systems that basically allow the beavers to remain in place while still managing the flooding impacts they cause. There's a lot of relocation of beavers, and I'm sure that Alexa will talk about that a little bit. Here in Washington, there are probably 8 to 10 different projects that are sort of moving beavers around the landscape, trying to repopulate drainages that used to have them and no longer do. And then in some cases, we're also trying to mimic their impacts, which Joe's going to address in his presentation. So, there are all these different things that we're sort of doing to coexist with these animals and, bring them back to the landscapes they used to occupy. So we've kind of entered this, this increasing beaver-human coexistence phase in our sort of ancient relationship with this really important animal. So why go to all the trouble for beavers? I mean, what do beavers do exactly that would incline us to want to restore them to their former domain? Well, first, of course, they're keystone species. We know that wetlands are life, and that any animal that creates and expands wetlands is really important. Here's a great blue heron rookery in a beaver pond in Wisconsin. So, wading birds, waterfowl, songbirds, any avian species does really, really well in and around beaver complexes. Of course, other semi-aquatic mammals, mink, muskrat, otters, moose are kind of classic beaver beneficiaries. Amphibians, here's a boreal toad, which in much of its range is basically a beaver pond obligate, breeds almost exclusively in beaver ponds. And then probably the most important driver of beaver restoration, at least here in the Northwest, is salmonids. If you're a little finger length steelhead, you don't want to live in the main stem river. You want to live in a pool or a side channel or an eddy or some kind of complex slow water refugia habitat, which of course is what beavers create. And then there are all kinds of sort of human or anthropocentric ecosystem services that beavers provide as well, which is really driving a lot of the interest in them. They're wonderful drought mitigators, right? We know that we're losing our snowpack here in the American West, and that beavers, by creating these little reservoirs, might be able to store some of that water for us. There's, lots of great studies basically, demonstrating this kind of beaver drought mitigation connection. They're wonderful irrigators, right? They're storing huge amounts of groundwater, which drives a lot of interest in the ranching community. This is James Rogers, a rancher in Nevada, who pointed out that beavers are basically increasing the forage production for his cattle tenfold. So there's, kind of a wonderful little agricultural set of beaver believers now in Nevada and Idaho and other states. They're wonderful pollution capture agents, right? They're basically creating settling ponds for nitrogen and phosphorus and heavy metals. They're sequestering lots of carbon as well, right? Every beaver pond is, full of organic matter. And when you do the math, a kind of the blue carbon sequestered in a beaver complex, it compares pretty well, pretty favorably to, a similar area of old growth forest. So they're wonderful pollution and carbon capturers as well. And they're fabulous flood mitigation agents, right? We think about beavers as being, being sort of causers of floods. But, you get a big pulse of flood water, racing downstream, and it hits that beaver complex, and that water spreads out laterally, or is stored in the pond, or is sunk into the ground. So, now beavers are being reintroduced in England and Scotland and other rainy places for their flood control benefits. So we've got all of these wonderful ecological services for both humans and non-human species. But what about wildfires? Of course, that's what we're here to talk about. And the kind of the beaver fire connection was something that was, for really decades, kind of anecdotally observed and hypothesized. Of course, here's an animal that's spreading water out in the landscape. It must be interacting with fire in some way. And when you read the kind of the historical beaver literature, there are some kind of tantalizing hints about this. Here's a quote from Enos Mills, who was an early beaver naturalist, who describes, finding this beaver colony in the middle of this giant burn, and the beaver colony was sort of the only feature on the landscape that had survived. And you start to wonder, well, maybe, maybe this is some kind of anecdotal evidence of beaver and fire influence. But this wasn't really, there wasn't really much or any peer-reviewed literature about the kind of the interactions between beavers and wildfire until very recently, when kind of the first of our three panelists today began to explore this issue. So we're going to hear from three folks today. The first is Emily Fairfax, who's a assistant professor at California State University, Channel Islands. And last year, Emily published a paper which really, I think, blew the whole beaver fire story wide open and put this issue on the map for a lot of people. So Emily will be talking about kind of the role of beavers during the moment of wildfire. What are these animals doing in the landscape as the fire kind of passes over? Alexa Whipple, the director of the Methow Beaver Project, will be talking a bit about the role of beavers in post-fire recovery and geomorphology. The Methow Beaver Project is, really one of the flagship beaver projects in certainly the country and probably the world. They've relocated more beavers than just about anybody. And then our third speaker will be Joe Wheaton. Joe's an associate professor of riverscapes at Utah State. What a cool title! And Joe's research group at Utah State is just they're just involved in every single beaver project and every single facet of beaver restoration and research that you can imagine. And I think that there's probably no research group doing more intensive beaver work in the United States than Joe's group at Utah State. So that's just all to kind of set the stage for our next three panelists. And with that, I'll turn it over to Emily.
Great, thank you, Ben. So Ben did a really great job of introducing beavers and what they do in general, and talking about all these incredible ecosystem services. And as he mentioned, what I'm going to be talking about is what happens during the fire. And the title of my talk is Smokey the Beaver, which is different than Smokey the Bear. So probably all of us here have at least heard of Smokey Bear or Smokey the Bear, and have heard the slogan, only you can prevent forest fires. I don't think Smokey Bear was the right mascot for forest fires, or maybe he was back in the day, but at least today he's not. Most of the imagery associated with Smokey Bear is referring to fires as our most shameful waste, and it's one careless match. Was it yours? Like, you need to prevent forest fires. And as Lenya mentioned, I don't think that is the right perspective to take with forest fire. We've had fires for a long time on this continent. They're not this horrible, shameful waste. They can be out of control, and they can be excessively damaging and exacerbated by the kinds of things that people have done to the landscape. But this whole Smokey Bear, only you can prevent forest fires, I wasn't super into it. It was too focused on fire prevention and stopping fires. It relies heavily on human interventions and like modifying our own behavior. And I can speak from my experience on a lot of different faculty meetings that it's hard to modify human behavior. It's hard to get people to do what you want. So whenever you're trying to pitch some sort of a fire mitigation strategy that involves people, you already have an uphill battle. And additionally, there's really this sort of outdated all or nothing approach with wildfire here. And I know that Smokey's had some PR rebranding in the last few years to kind of move away from that. But when you think of Smokey Bear, you think of only you can prevent forest fires. And that message is not modern, and it doesn't fit in with the way that we should be thinking about fires today. So instead of Smokey Bear, I studied Smokey the Beaver. And the whole thing with Smokey the Beaver, beyond just kind of riffing off Smokey Bear's name, is that there are animals that affect fire. And these natural processes like beaver activity are able to moderate fires in the landscape without us. We're not preventing fires. Beavers are not going out and putting on little firefighter hats and getting the hose and, extinguishing all the fires in the landscape. That's not what they do. But beavers can help really moderate the damage from a fire in the moment. And they work independently of humans. We don't need to be there. In fact, the beavers prefer that we are not in their ponds trying to micromanage them. They can handle it on their own. And the really impressive thing that I'll talk through in my talk today is that these beaver ponds, they can protect really sensitive species and protect ecosystems without suppressing that natural fire behavior. Because we want some fire, all fire is not bad, but we do need to protect these species like those frogs and those fish and moose and small mammals and birds and everything that can't outrun, outfly, or outswim the spread of the flames. So Smokey Beaver, totally different approach to wildfire than Smokey the Bear. And I want to start off by showing you a conceptual model for how beavers actually fight fire. So the title of the symposium kind of is a spoiler alert, like they do. And the panel of experts lined up for you today make it very clear that this is an established thing. But I want to start off by taking a step back and really talking about how does this work? How can beavers fight fire? The main reason that beavers are able to create these fire resistant patches in the landscape is because they've made it so incredibly complex from a hydrologic standpoint. We've got a landscape that I'm showing you here on the left, satellite image looking down from above. And if you spend all day looking at beaver ponds and satellite images like I do, you immediately know what you're looking at. But if you don't, that's okay. I have annotated some of the key features for you. So in yellow, you can see all the different beaver dams just in this relatively small area of landscape. And as been mentioned, a single family of beavers could be maintaining a dozen dams. And then they dig those little channels out from all these different ponds. And I've highlighted in blue the beaver channels that I can see with satellite images. So these are really large beaver channels. These are the bigger canals. I am certain that snaking through this landscape, there are a lot of smaller, more sort of fine-grained canals that I was not able to see in the satellites. And then I've circled in pinkish here the Beaver Lodge. And so this whole area, this incredibly complex landscape, this is not a single thread stream. This is a vast and very intricate wetland. It's being maintained by one family of beavers. So one family of beavers has effectively transformed a very simple river or stream system into this massive sponge in the landscape. All of these ponds and all of the soil around these ponds is able to soak up water whenever we have a wet period. And then when it's dry, it slowly wrings that out and the plants can access it and all that water can be used in the landscape, even if you don't have precipitation. And so beaver ponds are slowing, but not stopping the water. That's really key. When you think about dams, sometimes you think about the big concrete monoliths that humans build, and you're like, uh-oh, these are bad, right? They stop all the water and it totally disrupts the downstream ecosystem, but that's not what beavers are doing. What beavers are doing is just slowing it down. So I'm about to show you is a plot of stream flow over time. And so stream flow is just how much water we have coming through the stream at any point over the year. Now, in the American West, most of our water comes during the winter, either in the form of snow or rain, and it's accumulating and it's falling in the headwaters. And then as we roll into the spring and summer, that's when the plants want water. That's when they have sunlight. That's when they can really grow and do their photosynthesis if they have enough water. As we get into fall and late summer, that's where peak fire danger is typically. That's when we don't have a lot of rain coming. The plants still have all this sunlight. They really want to be growing, but there's not enough water. So they start to dry out and get a little crinkly. And so that's historically when we've had fire danger. Unfortunately, it kind of seems like we have fire danger year round now, and it's not fire season, but just fire time year round. But regardless, beavers can help with that. So in an undammed stream, in a stream without beavers, what you see usually is you don't have actually a lot of water coming through the streams during the winter. It's accumulating as snow or it's falling in the headwaters, it's taking its time. And then as we get into snowmelt season, as we get towards spring, you start to see a lot of water come through the rivers. And then it makes its way down towards the ocean. And by the time we get into the late summer, the streams are running dry or close to it, which is not good if you're a plant, right? You need to have water to stay green and healthy and happy. And if there's no water in the streams, how are you going to do that? Well, when beavers move in, remember, they're slowing down this water. And so what you have instead is as this big peak flow of snowmelt comes through, it hits these beaver ponds and it just spreads out. And those canals routed out into the landscape like little drip irrigation lines. And it fills the whole riparian zone with water. It's like a great big sponge filling up. And then as we get into this late summer period and into the fall when fire danger is really high, in the beaver dam streams, there's still water flowing. The landscape is still very, very wet, and that's huge. And that is the key to them being able to actually fight fire. The total amount of water coming through the system, about the same. You might have a little bit of losses in this beaver dammed area to groundwater recharge and to the plants actually using the water. But the biggest fear that I hear when I talk about Smokey the Beaver is like, what about downstream? Are we stopping the water? Are we going to lose the water downstream? And you don't. It might feel like that because you have this really big reduction in your peak flow during snowmelt period, but keep your eye on the stream in the late summer, early fall, and you'll see base flow has increased. So now consider these two streams, one with beavers and one without beavers. When we have rain, when it's like actively precipitating on the plants, which I'm showing here with these little green spiky things, their roots are happy. They can reach water. It's like you're going out with a watering can and watering the plants. It's totally fine. And it doesn't matter if we're in the stream without beavers, where there's a relatively small impact on the surrounding soils and groundwater, or if we're in a stream with beavers, where we've got all these little beaver canals and this great big beaver pond storing tons of water in the soil, because we've got rain. You're watering the plants, they're fine. But as soon as we enter drought conditions, that underground water becomes extremely critical for keeping these plants green. If their roots can't reach water, they will start to wither. They will shut down, they will senesce, they will go from that nice wet green state into this very kind of crunchy and dry golden brown state if they cannot reach any soil water. But in this stream with beavers, they were spending all of that wet period storing the water in the soil. And so all these plant roots are still fine. There's no precipitation falling on this landscape at this point, but these plants have essentially been drip irrigated by the beaver canals. And then if you think about what that means, what the state of this vegetation means when we have, I don't know, one careless match, or maybe a power line if you're in California, what would happen? Dry plants are definitely fire fuel, right? As soon as they dry up, all that biomass becomes just ready to burn in an instant. But what about wet plants? When you have a bunch of wet plants, they're not going to burn. It's just simple physics. It's water. It's too wet. The fire would much rather burn something that's dry and easy to ignite than something that's going to take forever to dry out and then burn. And so when you don't have beavers, all of this vegetation that started to wither during a dry period suddenly becomes fire fuel, ready to burn. When you have the beavers, though, these plants stayed green and wet. They never reached that fuel state, and so they don't burn, at least theoretically. I have also developed this conceptual model in another way. I like using these scientific diagrams and figures. That's how sort of my brain thinks. But when I talk about this with people, sometimes I think it's easier to just see it rather than have it explained. He's okay, right? That's great. He made it. That is essentially my conceptual model, except made with felt and cardstock instead of made with Adobe Illustrator. And this is huge, right? He's okay, the pond is okay, the wetland's okay, and anything living in that wetland is okay, at least in my theoretical model. And luckily, this model was sort of documented in the real world outside of my felt by Joe Wheaton, who's going to be talking to you later today. He took this great photograph, which I think you've now seen 3 times. That's how great it is. And what we've got in the middle is just a bunch of beaver ponds, and on either side of them is a super burned landscape. And this is from the Sharps Fire up in Idaho. And he said, which I think was very on point, it turns out that water doesn't burn, right? And this was observed. And I thought this was incredible. This is proof that this happens at least sometimes. But what I wasn't sure of is this a repeatable phenomena? Does this happen all the time? Or were these beavers just lucky? And some other thing, maybe the shape of the landscape, or who knows what prevented this little patch from burning. So that's what I wanted to test in my study. And the title of my study was Smokey the Beaver, because once I came up with that on a walk, I just never let it go. And that's what I was looking at. Does this happen over and over? Is this repeatable? Is this something that is a reliable effect of beaver damming? And I looked at 5 fires in 5 different states throughout the American West that at the time I thought were really large fires, and now I don't really feel that way anymore. But they ranged from 21,000 to 395,000 acres. And I'm just going to show you a little bit of my data from the California Mantor Fire. Now, this burned in part of Sequoia National Forest called the Domeland Wilderness in the summer of 2000. And it was 79,000 acres, and this area had just a ton of beavers in it. And it still does. It had beavers 25 years ago. It still has a bunch of beavers today. This is me standing by a beaver dam in the late fall. You can see it's a pretty sizable one, even with not a whole lot of tree cover in this area. And this beaver complex is huge. Like this dam that I'm highlighting for you now, this is about 300 feet long. This is an absolutely enormous complex. These beavers have been seriously modifying this landscape for a long time and have been storing a lot of water for a long time. And I was really excited about this sort of set of fires that I was looking at because they were extreme. And I wanted to see the extreme limit of beavers firefighting impacts. Can this happen even in the worst of fires? And to keep myself grounded in what these fires were actually like, I looked up a quote from the LA Times about the Mantor Fire. It is a humbling expression of nature, walls of flame 70 feet high, twice as high as the nearest tree, leaping through canyons and valleys, at times in 5 directions at once. Left behind, quite literally, is scorched earth. So this was a huge fire. We've established that beavers are huge rodents, but they are not 70 feet high like these walls of flame. And this is fire to actually scorch the earth. That indicates that it is an extremely hot fire. You don't burn the soil in a casual little brush fire. This is a big fire. And there's a lot of beavers in here. And I was very excited to see what happened to them during this fire. So imagine that in every creek that I'm studying, you are walking along the creek. And you're taking note as you go of how green are the plants and how far you've walked along the creek. And you do that in the year before the fire, and you do that during the fire, and then you do that after the fire. Now, obviously, you can't do that during the fire. It's dangerous. So I did this, but with satellite data instead of actually going out and walking these creeks. And what I saw was that when you're in the area with beaver dams, which I've denoted with these little black boxes on the x-axis here, we have the plant greenness is relatively stable in the years before and after and during the fire. So green is before and after the fire, and then this brownish red color, that's during the fire. Higher values, more green plants, lower values, less green plants. When we're in the beaver dammed area, who cares if it's before, during, after the fire? All these are about the same. However, as soon as we get out of this beaver dammed area of the creek, we can see that during the fire in this reddish brown curve, the plant greenness drops. It's like big drop. Before and after the fire, pretty fine. During the fire, massive drop. And so what this is indicating is that these beaver dams were sort of preventing fire damage from happening during the fire. And to make that more clear, I'm now just showing you the difference between the pre-post state of the fire and then during the fire. So now a higher value is indicating that you have been more affected by the wildfire, and a lower value is indicating you've been less affected by the wildfire. And again, these little black boxes are the positions of beaver dams. And it's pretty clear there's not a lot of fire effect when we're in the beaver dammed area. And as soon as we're out of it, really large fire effect. And I saw this on every single creek in my study. And I saw this in photographs taken of my study sites immediately after the fire hit them. We can see this tree burned by those 70-foot walls of flame. We can see the scorched earth on this section of the creek that did not have any beaver dams. We can see burning soil, and the fire front had approached this area and then couldn't burn it anymore. And that's thanks to this beaver dam. So these beavers created a portion of the landscape that was so wet that even 70-foot walls of flame that can leap through canyons and valleys could not burn the beaver pond. And that was incredible. And I saw this in all of my fires on all of my rivers. It was definitely a repeatable effect. Overall, the areas with beavers were about 3 times as protected from the fire when you compare them to the areas without beavers. So these beavers are offering an enormous amount of fire protection during the fire. They're keeping these spots green and healthy and happy, even if you've got flames everywhere else in the landscape. And if you're an animal trying to, avoid this fire, we've got the beaver dam up here. Now we've switched perspective. There's our burned trees. Where are you going to go when there's a fire? You're going to go somewhere that's not going to burn. And this black bear was actually photographed immediately after the Mantor fire, hunkering down in the beaver pond. This is proof. These beavers are creating refuge during fire consistently that other animals and plants can take advantage of. They can survive these massive fires. They can survive fires that are burning hotter or more intense than they did historically by moving to the beaver ponds and just waiting it out. And so I like to say on this slide that it looks like Smokey Bear got a little helping hand from Smokey the Beaver, at least in this case. And so your take-home messages overall, when you've got beavers, we're only seeing about 19% of the maximum damage you could expect in those riparian zones. You can literally see green patches from aerial photos and satellite photos all around these beaver dams and in these beaver wetlands. I saw this happen in all sorts of different climates, land covers, previous conditions, whether it was a drought year or a wet year, didn't matter. These beaver ponds were keeping it green during fire. And that has a lot of potential for post-fire impacts as well. So when you protected that ecosystem during fire and the rest of the landscape is burned, there's potential for that to sort of be a seed to recolonize the rest of the landscape and spread back out and promote ecosystem regrowth. There's also potential after a fire to have flooding, which can lead to massive debris flows. But all of these beaver ponds, they're great at slowing the flow, just like Ben said. And so they can help potentially attenuate some of that post-fire damage as well. Now, the opposite was true in the stream without beavers. We saw about 58% reduction in plant health on average, a lot of burned vegetation, scorched soil. You have issues with invasive plants recolonizing after burn in some places, but if you never burn it, then there's never an opportunity for the invasives to recolonize it. So I think there's a lot of potential for beavers to help out with the post-fire stuff. But what I studied and what I'm most excited about is that when you have a fire, these beavers create a refuge that protects plants and animals and the ecosystem, even from some pretty extreme fires. And so if you have questions for me, save them till the end. I'm super excited now to turn it over to Alexa, who's going to show us a little bit about the post-fire beaver world.
Well, good morning and good afternoon, everyone. Happy Earth Day. What an amazing subject to celebrate beavers and how they can potentially build resilience and resistance to fire on our landscapes, and how lucky we are to have beavers as a native species within our ecological systems. Our Earth would not be the same without water, and our watersheds are not the same without beavers. So I'm going to talk mostly about rebounding from wildfires with beavers and their help. Most of my work has centered around 5 to 6 to now 7, 8 years after wildfire. And what I really was building this research came to me as something that needed to be understood and studied better after we experienced incredibly large fires up in Washington state. At the time, it was the largest fire in 2014, over 250,000 acres burned in 2014 within the Methow Valley. And the next year, we beat our own record and over 600,000 acres burned in Washington state. So it's been a rough couple, decade almost of fire, but even more so building up to that. So I'm going to get my second slide to just say thank you to Beavers for being willing to work with us on the landscape. The Methow Beaver Project, who I work for and the project director for, we count on partnering with Beavers a great deal, and we have that responsibility to be a good partner to Beavers. We started partnering with Beavers to store water on the landscape, and now we've built that to mean increasing biodiversity, increasing climate refugia, and even fighting and recovering from wildfires. I wanted to start just by echoing so much of what Dr. Emily Fairfax has shared with us, is that Beavers already on the landscape and building dams and establishing complexes, that's built in wildfire resilience, as her work has shown and anecdotally has shown over the years. Water doesn't burn. We have a lot to thank Beavers for when they are on the landscape and help our communities not only resist fire, but recover from it as those seeds of plants and animals when they find refugia there. So I just wanted to give a couple examples in our area where Beavers have been during fire. Here you can see one spot where the terrestrial ground on the left of the pond, this is a beaver pond, burned right down to the pond, but on the right, it did not. The pond of these beavers actually slowed the fire down, didn't stop it, but slowed it down and saved a fair bit of habitat on the right side of the image. This is another photo right after fire, where a beaver complex reduced the impact of wildfire right within the vicinity of the pond. So just wanted to share those images that are building on Emily's research in our neck of the woods up here in Washington state. This is right after the 2014 Carlton Complex fires. I'm going to move through a couple images pretty quick, showing streams that burned in these large and severe fires. That this was unusual fire conditions in Washington state, that we had fires move through this area in a matter of days due to high winds and high lightning strikes. So we had quite a few fires and quite a bit of wind to carry it through, which is what a lot of folks are experiencing these days. So just another stream in riparian zone. This one was blown out with a debris flow. This one burned severely, but not a scorched earth system, but much of this fire did scorch the earth. This is another fire just last year in an agricultural sagebrush steppe zone. You can see that there is some legacy degradation in this system, not just recent burning, but actually you have incision formed from moving water for agricultural purposes as well as livestock damage. This is an area right after fire where there was human-built dams that then blew out because they are generally not the speed bumps as Ben described. It's a single dam holding water for irrigation, and they're very susceptible to damage, especially during high flow events, without redundancy, as beavers can offer. This is 5 years post wildfire in our neck of the woods. This is severe incision. This is nearly 2 meters of incision after debris flow came through after wildfire. So we're showing that, what I wanted to show you with these slides is that right after fire isn't always the time when we're seeing the greatest degradation in our streams. That is the result of, yes, legacy impacts from historic use of these streams, but then the short-term impacts of storms and precipitation runoff after wildfire, when there isn't a vegetation on those hillsides anymore to slow water down. It all comes down at once and causes severe incision in these channels. So this is what I'm trying to demonstrate, is anywhere from 1.5 to 2+ meters of incision in many of our streams, the year of the fire and even years following fire in big precipitation events. This one is over 2 meters. I mean, it's just shocking what you see on our watershed landscape after fire. Again, almost 2 meters of incision in this site. So when I saw the results over the year or two following the 2014 Carlton Complex fires in our neck of the woods, I started really thinking hard, like, how are these areas going to recover after wildfire and the extreme channel erosion incision? And what I saw in my neck of the woods is the Meadow Beaver Project, working with beavers to move them out of conflict situations up into headwater streams, conflict with private landowners, primarily in our larger tributaries, moving them into public lands up in headwater streams to try to allow them to provide the ecological benefit that they can in a place where they're not in conflict with people. And so I started wondering, like, okay, so could beavers potentially help restore the channel incision after fire? And so that's where the question started for me. I had to back up, and as Lenya wonderfully shared with us more on fire's history, fire is an essential part of our ecosystems. But since Europeans moved into North America, they've really started to control and manage resources more intensively, and oftentimes for economic gain above ecological gain. So we started to suppress fires, and even though fires in coniferous forests were fairly frequent, they were often smaller and at lower severity. And you had many fires burn, as Lenya pointed out. You had a lot of acreage burned, but not at the same intensity or severity within a year or even 10 years. And so when we started applying institutional suppression of fires to protect economic interests as well as human communities, we started allowing our forests to become denser in their understory, which, as many of you in fire know, that becomes ladder fuels that can bring what could be a small scale, low severity fire. Those ladder fuels or small understory trees can then bring fire into our canopies of our forests and then cause canopy or crown fires that can be stand replacing events, and often are these days. So that's the change we're really looking at a lot of the time, at least in Western arid forests, is that we're going from these small scale understory burning fires historically to these larger scale ladder fuel rich canopy burn and stand replacing fires. So that high severity is not doing us any favors. We're looking at a great figure from Weber et al. To 2018 that shows the increasing frequency of fires greater than 100,000 acres. So historically, on record, there were no fires greater than 100,000 acres prior to the 1970s, at least not that we knew of and had been recorded as such. But since the 1970s, we've had many. And since 2016, at which this graph goes to, we've had plenty more. So we're starting to see larger and larger fires, even though there are not as many fires because they're becoming complexes of fire. We can't count as many of them anymore, but their severity and their size is increasing. Part of that is due to climate change. Temperatures warming in the atmosphere, a lot more evapotranspiration. That sends more water into our atmosphere, which becomes or stimulates more energetic processes within storm systems, causing more lightning and often more intense downbursts from these energetic storms. So through drought, we actually lose more water, obviously, but it goes into the atmosphere, which then is causing more energetic storms. So, you have a really complex set of systems all interacting together. And when they do, sometimes the consequences are dire. This is what we saw in a lot of the Medhow Valley and the Okanagan Valley when fires burned in 2014, 15, and since then, and most years since then, that we are seeing extreme heat. So we're having incredibly high risk of erodible soils afterwards. We're seeing pyrolysis on the soils, which means they become non-absorbent, and any water that does fall on them, it actually acts as ball bearings and sends sediment down slope to the nearest common denominator, which is our streams. So what we're seeing after these severe fires on a large scale And if we have storms or precipitation events following them within this couple months or even years, what we are seeing is incredibly deep channel incision after that, because when water carries soil and rocks in it, it actually can start carrying much bigger things with its density or viscosity. So we're seeing incredible incision with all the debris coming down with precipitation events after fire, because there's no vegetation or very little vegetation left to hold it. So all that scouring of our channels, of our water system, is disconnecting floodplains from their streams. It's making the channels too deep for water to get out, even during high flow events. This reduces flood control that we see on our landscape in our watersheds, reduces water storage and water quality, reduces stream complexity, habitat and biodiversity, and lowers our water tables. So a lot of those plants, as you see in this picture here, this is a couple years after fire, they're barely hanging on in this area because they don't have water anywhere near their root systems anymore. Luckily, we have a lot of snowpack here, so some plants are getting by even without that, but we're certainly not having the connectivity of high flows to our floodplains, which is what really creates a very productive ecological system. So one of the things I wanted to look at is like water quality. What are our fires doing to our water quality? Well, nutrient transport is a big deal when you have all that debris and sediment coming down after fires. You have nitrogen and phosphorus in particular that are limited nutrients in our environment. And when they come down in high concentrations and concentrate in certain areas, they can cause major water chemistry changes. And some of those changes can be very detrimental to any other aquatic organisms in the system. Eutrophication is one of those occurrences where you have many issues with dissolved oxygen, as well as phosphorus. I don't want to get too deep for everybody because there's a lot to water chemistry, but when you have blooms of algae, which are caused by high nutrient, high phosphate, high nitrogen loading, you impact the rest of the aquatic system in a very detrimental way, which when we're looking at the species that require other aquatic organisms for their food web, like salmonids, you're looking at macroinvertebrates who are really being impacted by pH, by phosphate concentrations, by nitrate concentrations being increased, by debris flow that brings sediment and nutrients down into an aquatic system. So my burning question became, how do we fix this? I looked at the stream evolution process from Clure and Thorne, like, okay, is it just time to take a stream that, as this arrow shows, is in a dynamic and complex state? Then you have a disturbance event like a brief after wildfire, which creates a very narrow channel. And over time, you have widening of that channel as structure falls into a stream, and eventually that structure slows water down and starts aggrading or gathering sediment. Deposition is what that's called. And then you go back to this complex channel form, which looks really good and very productive. But this is a logarithmic time scale. This is happening in the hundreds of thousands of years. And we've had a lot of streams impacted by fire and debris flow. I don't think we can wait that long for them to recover naturally. And some of them aren't going to recover because we're living in a very human-dominated system where there's often limited access or flexibility on streams accessing their floodplains anymore because of human development and road structures and infrastructure in general. So we call that a stable state of incision. A lot of that's come from mining, legacy degradation from timber harvest, from irrigation abstraction, as well as livestock grazing. This is a dramatic picture that I always refer to when I think about livestock on our dry, arid landscapes and how they impact streams, because livestock need water too, and they always find it. So is river engineering the answer? I didn't think so. I mean, these kind of projects are really important and done by our parent organization, Methow Salmon Recovery Foundation, trying to recreate habitat for salmonids in our main stem streams that have mostly been rip-wrapped or armored to protect human infrastructure, or narrowed and straightened. So there's a lot of challenges on every portion of our watershed. But this This kind of restoration is not scalable after these mega fires that are impacting our headwater streams all the way down to our main stem tributaries. However, there's a native species here that historically was in most of the watershed all the way up into the alpine zone. Any place where they could slow water down, they did, because it was to their benefit to do so. So could they be the answer to helping us recover from severe stream incision, whether it's from wildfire, which we're seeing increases in severity of stream incision, and as well as legacy degradation in our streams? They're incredible ecosystem engineers, as Ben already elaborated on. So I won't spend too much time there. We know they can do the job if they're given a chance. Dam building, as Ben already elaborated on, increases water quality, water storage, sediment and nutrient capture, stream complexity, attenuates floods, helps store carbon, reconnects streams to their floodplains, and improves habitat for so many species and increases biodiversity. And again, it's a beautiful, beautiful artistic rendering of the diversity that beavers support by Sarah Gilman. Just had to share that. Pretty. So again, as Ben discussed, well, why aren't beavers doing the job then? Why aren't they doing it already? Well, they were nearly extirpated, as he described, in the early 1800s. And ever since then, Europeans have moved into the habitat that was prime habitat for beavers, and it's still their stronghold, which is the main stem rivers and larger tributaries where beavers don't usually build dams unless they have the opportunity to do in a side channel, off channel habitat. And that's where Europeans have moved in. They're not tolerating beavers as well. They've been thought of as a nuisance by more people than have thought of them as an ecological benefit or recognize them as such. Most of us have that ecological amnesia that we don't know a beavered landscape or watershed anymore. It was not even the earliest settlers who knew that landscape because those beavers were trapped out before people started to settle there. But our floodplains became agricultural lands that have fed us for many, many, many years. And now we have to look back at that and say, wait a minute, we're not going to have this much longer if we don't start trying to restore the processes that allowed sediment and nutrients to move in a reasonable way, in a slow way, and capitalize on beavers' ability to store water in these landscapes again. So I know I could talk about beavers for days and days and days, but I'm going to try to move through this quickly so you get the majority of my research that I've done specifically on beavers, channel erosion, and wildfire. But the Meadow Beaver Project does so many things. So if you have more interest, certainly go to our website, give me a call, send me an email. Happy to talk more about any specific interests around anything I mention or don't mention today having to do with beavers, because we do a lot of different stuff. So I'm going to launch into where we've studied this specific interaction between wildfire, channel erosion, and beavers, and that is in the Meadow River watershed up in north central Washington. As you can see from the map, we have a pretty large watershed, and this beautiful area, I want to acknowledge that these are the ancestral lands of the Meadow and Okanagan people here, and we are occupying these lands ever since the 1700s, unceded lands from this tribe of people that's part of the 12 confederated tribes of the Colville Reservation. And just wanted to mention that because the Beaver Project is committed to working on ecological restoration, but also cultural restoration with the ancestral people of these lands. So when we are looking at fire, I'm going to walk you through a little tableau of wildfire in the Meadow Valley since 2000. So when you see a colored orangey area light up, that's the acres burned during a fire during this period represented. This one, 2000 to 2003. The next one, 2006, the Tripod Fire burned that much more of our watershed. 2014, the Carlton Complex burned that much more of our watershed. 2015, the Okanagan Complex burned parts of our watershed. 2017, we had more areas and some reburn. In each of these fires, there's been reburn when they've been on the edges of previous fires. 2018, nearly half of our watershed has burned in 20 years. So we're looking at some pretty extreme wildfire behavior. For channel erosion, these are some of the areas that I studied looking at channel erosion 5 years after fire. Again, you're having anywhere from 1+ meter of incision all the way up to 2.5 meters of incision in some of our channels. And then beavers. We have the Meadow Beaver Project here in the Meadow Valley since 2008. We've relocated and partnered with over 400 beavers, not by their choice, but they did survive because we only relocate from conflict conditions where lethal removal would be the only other option. So over 400 beavers have partnered with us, relocate from conflict. We have been a pioneer in relocating beavers and beaver husbandry, in pairing beavers. This is a picture of a former incredible biologist who helped pioneer sexing beavers, which is now done not from blood samples anymore, but from actually the scent of castor glands, or anal glands, excuse me, anal glands, which can be identified male, female smelling more like cheese, males more like motor oil. So we actually try to pair beavers when we capture them singly so we can release them out into the wild as a mated pair. There's a lot that goes into that. If you want more information, feel free to get a hold of me. But then we release them into pre-assessed sites that we know can support beavers. But what we are finding, I'm going to go back up, is that beavers don't always want to stay where you put them. So this isn't the end-all be-all answer to restoring beavers to our landscape. Many of our beavers come right back down from public headwater streams back into the main stem tributaries, especially if they lose a mate. We have a predator-rich environment, so they come on back down, and then we start over again. So we're looking at, we have to expand and create a lot more tools in our basket to managing beavers for ecological benefit as well as other challenges. There's a lot more to that. But what I wanted to look at is, do beavers improve water quality after fire? Can they increase channel complexity or accelerate channel evolution? And can they improve habitat structure via vegetation after fire? So I went to a lot of these relocation sites where we had put beavers before and that had experienced fire. And a lot of those sites, the beavers didn't exist anymore in some places, but in some places they came back after fire. And that's the areas that I chose to study for my research, is where beavers had returned after wildfire and channel incision. So when I looked at improving water quality, I'm going to just get really specific on what I share with you. There's a lot more to this research, and it's available on ResearchGate if you want to go find it. But I mostly looked at phosphate transport when I looked at water quality and the impact of nutrient concentration, because phosphate is transported adhering or absorbing to sediment. So you get a lot of phosphate movement, which is a very limited nutrient in the environment until there's a big event that moves sediment typically. So what I found when I did research in all of my study sites is that if you look at this figure, you'll see dissolved phosphate on the y-axis or on the left, and beaver presence or absence on the bottom. And the orange lines represent burned sites that I worked in. So if you look at this next slide that has the circle where we had burned sites and there were beavers absent, I'll use my cursor here. Beavers were absent. You then see that there was a high level of dissolved phosphate in these streams where beavers were absent. So in the next figure, where beavers were present, dissolved phosphate decreased so low that it matched the green lines, which is where there was no fire in these streams. So there's been some great studies showing that phosphate is moving after wildfires for 5 to 15 years because of precipitation events and very little veg on the landscape, letting sediment move into stream systems, and phosphate is adsorbed to sediment. So beavers, 5 years after fire, were sequestering that phosphate in their beaver complexes as if the fire had not occurred. So that was pretty dramatic and blew my mind, and I was very excited to have done that water quality study. It was kind of a last-minute addition to my research. But we also saw that pH was reduced in these systems where there were beavers and after wildfire. So pH was brought down, and that's a huge benefit for our macroinvertebrates, which are then the base of the food web, or close to the base of the food web for so many of our critters. And so increasing channel complexity, I looked at channel cross sections on the stream evolution process for all of my streams that I looked at. And width depth ratio was the most intriguing for all of the aspects that I measured in these channels. And a large ratio coincides with this complex system. A small ratio coincides with these really severely impacted and eroded systems. And what we found were beavers without fire had really large width depth ratios, looked like the complex system that the arrow is pointing to. Where there were no beavers and there was fire, you had this severe degradation, the incising event, and a really low width depth ratio on our channels. Where we had beavers and fire, we accelerated that stream evolution process all the way over to the aggrading, widening and aggrading step, and a mid-range width depth ratio. So what that showed me was that beavers were accelerating the stream evolution process. I'm going to show this slide in particular because it shows the incision event of fire with no beaver and then fire with beaver. And you can tell a big difference that within 5 years, we were already moving past the incision event into the recovery portion of the evolution channel, or cycle, sorry. So that gave me a lot of hope personally, as well as for potential recovery of all systems after fire with beaver, that we can accelerate recovery after fire with beavers. This is, again, this is stats where it just showed that beavers do increase with depth ratios in general, with fire and without. All of this is in on ResearchGate if anyone wants to take a closer look. And then improving habitat structure via vegetation. This was probably the biggest part of my study and the hardest part to talk about, mostly because beavers do alter plant species and structure composition of vegetation communities, but it takes a lot of effort to measure that. That is identifying every species of plant within each of your transects through your sites. But when it all came down to it, and identifying strata, meaning what level were these plants in? Were they in herb, shrub, understory, canopy, emergent, or snag columns? And what we mostly focused on was the shrub and understory, because those were the food preferences for beaver primarily, or food needs. In our neck of the woods, where they have to put a cache away for winter, they need woody shrubs and trees for that. And what we found was that there's an increase in woody riparian species after fire. Most of these species that naturally occur here are native. They've also evolved with fire and respond really well to fire. Even though the landscape can look charred and blank, like a blank slate to start over, all these species have evolved with that cyclical occurrence of wiping the slate clean. And in some ways, that allowed our native species to outcompete some of the annual invasive species. And that was one of the most exciting things I saw, was that our native species rebounded faster in a lot of my sites than the invasive species could rebound or move back in. That changes. You know, we're now starting to see that 8 years after fire, that the invasives are coming back in and getting a foothold. So that is a strong argument for cyclical burning on a more frequent scale, smaller scale, lower severity. I'm not going to go through that figure. That's the NPS figure, which is so interesting and fascinating. But if anybody wants to call and talk about it, I would happily share that with you. But this is what burn systems with beaver look like 5 and 6 years after fires. Just incredibly lush with woody species rebounding after fire. So in review, beaver activity does increase water quality by sequestering phosphorus, sediment, carbon, all of those things that would go downstream and impact other reaches of the stream, even ones that have more critical species, like our endangered salmons in the Pacific Northwest. A lot of those salmon aren't getting into the upper reaches for various reasons, but if we can hold that nutrient in place and then put it in the carbons and into sequestration and sedimentation, we are gaining benefits downstream even. We are accelerating channel evolution and increasing the opportunity for floodplain connectivity and complexity when we have beavers in burn systems. And then we're shifting species composition of vegetation back towards a system that did not experience fire with beaver, more towards woody species and shrubs in that understory layer. So have we answered the question, can beavers help increase recovery after channel incision and fire? Well, yes, damn right, they do help. Do we need a lot more of them on the landscape? Yes, we do. But here are a couple really hopeful images of beavers on our landscape where there was severe channel incision 5-6 years after wildfire. So I just wanted to share these visuals with you of a landscape recovering with beavers as a partner in restoration. So one of the beautiful things that I really want to share with everyone, especially Dr. Fairfax and Dr. Wheaton, is one of the things we're seeing in recovery in burn systems, especially with severely incised systems, is that beavers are often honing in on springs. And maybe you all already are clear on that point, but when beavers can't get into an incised channel because of the high flow events that still occur afterwards and act like fire hoses coming down through the incised channels, the water acts like a fire hose. We're finding that beavers really are keying in on springs and building off of those springs until they have built up enough structure by downing and felling trees and digging canals that then they move into the incised channels and start damming those as well. So I have some really exciting sites that are continually evolving with beavers finally moving into the actual incised channel when they weren't at first. This is one of those sites too, as a second one, where this huge pond has developed and the channel itself is severely incised, even with this pond just to the side of it. But now beavers have started building dams. If you see the arrow in the previous picture and the arrow in this picture, beavers have already started damming that main channel and have raised the stream bed and water level by several feet. It's very exciting, I have to say. And here's a larger shot of that channel that was severely eroded after the 2014 fires, now has a series of at least 8 beaver dams in this narrow channel, which is only about 3 meters, 4 meters across in different spots. But the beavers have already started grading it. They're not back up to the floodplain yet, but they're working hard and getting there fast. This is 2 years of beaver dams in that channel after 4 or 5 years of that spring being built, helping build that beaver complex just adjacent to this channel. So we're seeing that in a few places after severe channel erosion, and that is very exciting too. This is just another example of them bringing up the water line in a burned, eroded system, and there that water line has come up about 2.5 feet in just 2 years. So that's very exciting. So strong evidence that beaver introduction be low tech, low cost, process-based, self-sustaining and scalable strategy for riparian and stream channel restoration after wildfire. And when we can't get beavers in there, and this is what Dr. Joe Wheaton is going to talk about right after me, is sometimes we need to be the really good partner to help make areas more favorable for beaver establishment. And that can mean adding structure to streams ourselves. I'm going to let Dr. Wheaton talk about that, but he has inspired so many of us who are working with beavers to get in the stream ourselves and start making the repairs to jumpstart the channel evolution process and give beavers a better chance of sticking where we put them when we do need to relocate them, ideally into a place that has had restoration started already with our human efforts. Here's a place where we've added more structure within a few months. The red arrow points to beavers building off of our structures in the anadromous zone, meaning where salmon are existing and needing more habitat, and they're already using it, and beavers are already using it too. And then go back to what Ben said, we need to prioritize the coexistence factor when beavers do show up and start increasing the ecological benefits in an area. We've got to help people live with the beavers that they don't have memory of sharing land with, or waterfront with, or their wetland or their pond or their side channel. So we have to help. We have to increase the number of ways that people can access those services and that education and understanding. We are all about finding solutions to coexist with all beavers. And this is one of my favorite shots from one of our trail cams at a site where we put in a pond leveler or a beaver deceiver, and you have coho salmon swimming with beavers in this complex, and those coho would not have gotten into that beaver complex because of a simplified human system, a single channel with one outlet, without that pond leveling device that also offered fish passage. Controversial area of study. If you want to know more about it, there's going to be an upcoming opportunity with River Restoration Northwest if you're up in the Pacific Northwest. And then management. Increasing management options for protecting beaver populations. There may be a place for recreational and commercial trapping for beaver, but it's not everywhere. And that's one of the things we're really working hard on with our Washington Department of Fish and Wildlife, is protecting beavers where we are partnering with them for restoration. And we do need to limit harvest when we are dependent on beavers for their ecological benefits. We got to be a good partner there. We can't just set them up to fail. So much more to that for a keystone species who deserves management for that ecological benefit they provide. So I quickly just want to thank all our partners and collaborators. We work with so many folks, and we're grateful for all the partnerships that we've been blessed with, especially our beaver partners. And I just want to thank you very much and give it to Dr. Joe Wheaton, who's got so much to share on low-tech process-based restoration, including beavers as one of those processes. Thank you.
That was great. Alexa, thanks so much. And thanks to the other speakers for some great talks. I will attempt to get us to questions by our closing time here, and then we'll spill over after that if you have questions, and we're happy to chat. So I want to talk a little bit about this low-tech process-based restoration, and probably the least of any of the presentations actually on beaver, even though I love to talk about beaver. What I am going to try to do is talk about where are the opportunities where, like Alexa set up for us at the end there, it might make sense to intervene. And one of them is, where we can use low-tech process-based restoration and beaver for fire resilience. And so we learned from Emily about that, as well as Alexa. And then from Alexa, we also heard about, how beaver on their own can bring in post-fire recovery. And I'm going to talk a little bit about this emergency restoration, as well as how we can, if we have the foresight, we can do some of this process-based restoration ahead of time to avoid as catastrophic changes as some of what Alexa showed us post-fire. And so this idea of resilience, if beaver are already there before the fire, if we have the foresight to try to encourage that, or they have the ingenuity to do it on their own, we see these sort of recurring responses like this, which are very encouraging. And then, this example that we've seen a bunch of times from the Baugh Creek watershed up in Idaho. This was thanks to the beaver for sure, but it was also thanks to some foresight from Terry Gregory at Idaho Fish and Game, who was the guy who quietly 20 years prior started reintroducing beaver back to a system they had been entirely extirpated from, much like the ingenuity of the Methow Beaver Project. And so Terry got beaver into these systems, and they were the reason that we have these nice sort of visuals up here. But a lot of what's behind Terry here is actually, we'll come back to a little later, is a lot of what the rest of the watershed looked like where beaver hadn't gotten to. And so we were actually in discussions with Terry about, well, how can we help beaver spread into some of these areas that just weren't as desirable and suitable for them. Terry, of course, had the inspiration of the parachuting beaver that Idaho Fish and Game employees back in the 40s and 50s before him had done some of this sort of restoration. And, we've heard this theme today of resilience. Now we're going to be talking about how we can manage these landscapes as critical natural infrastructure, these riverscapes, for resilience. And it's, of the thing you care about, put whatever you want in the blank here. But to what? And so if resilience is the capacity to recover quickly from difficulties, toughness, etc., or a lack of sensitivity to disturbance, obviously the resilience too, we've been talking about fire, but as Alexa highlighted, post-fire, we often, see the floods and debris flows, etc., those sorts of disturbances come in. So the things that could really impact these systems. And so if we can build resilience with the help of beaver and natural processes in these systems, obviously we're all singing that tune as a good thing. I just want to encourage us to, as we work with diverse partners, sometimes the beaver thing is, we have a friendly audience like this and it's easy discussion. Other times people don't want to hear about beaver. So we don't have to fill in the blank on resiliency of what all the time. We can just talk about resiliency and people can put in there whatever it is that they want. But it is a real estate problem of wetting up these sponges, and Emily really nicely highlighted some of the mechanisms behind that. So what's encouraging in really the past decade, we've seen a real sort of synthesis and consolidation of a lot of science that was sort of pointing out that our study of riverscapes was studying it prior after we have impacted them so heavily. And a lot of our conceptual models were off. And really what's kind of happened is we've realized that these things aren't anomalies. Ben did a fantastic job in his book of sort of painting this picture with prose of what could these landscapes look like, what did they look like, and that beaver were so critical to really structurally forcing this sort of resilience in these systems. We have horrible nerds. Well, yes, we have that too. We have horrible terms like anastomosing, which often referred to stage 0 and stage 8, which is just where we have multi-threaded flow around these vegetated islands. And it's structurally forced. This is not a picture of a flooded landscape at high flow. This is a picture of a flooded landscape at low flow. Thank you, beaver. And so this messiness, science has finally helped us articulate that this is okay to shoot for and what it means and just how important beaver were. And I was so inspired by Lenya's talk and just hearing those parallels between how fire and beaver have both been chastised, but are now being, sort of celebrated as the processes we need to get back. What we've tried to do to synthesize a lot of that science to kind of guide our restoration is if you're going to go restore a landscape, you need to have something to shoot for. So what constitutes a healthy riverscape? And it turns out these 4 principles will help us out a bunch. 1, streams need space. How much space? Well, they need their valley bottoms. They need not just the channels, but the channel and the floodplain. That's that natural infrastructure, that real estate that's so critical. Within that, if structure through beaver dams, through wood accumulations and jams, through rhizomatous root zones, et cetera, those things force complexity, and that builds a more resilient deposit within this valley bottom, not just loose, unconsolidated sediment like we saw in those debris flows that comes in and then it just cuts right back down through that super fast, but instead this carbon fiber matrix of sediment and roots and wood, et cetera, that have better water holding capacity and are more resilient to disturbance. How important this stuff is, it depends. It's our 2 favorite words in the natural sciences, and it depends on things you can go study and get degrees in. But that's, beaver aren't the answer everywhere. Wood is not the answer everywhere. We have ways of sort of reading the landscape to know where they were appropriate, et cetera. And then inefficiency, which Emily talked to us, it's a shame that we refer to these as drainage networks. These are more than just drains of free flowing nothing. Actually, the less efficiently they drain, the better the benefits to the ecosystem. And so this is really, really important to kind of recognize that these sorts of principles, they help us with a target. Now, there's a lot of ways to get there, and there's a lot of different flavors of process-based restoration. That is restoration methods that are focused not on fixing the form, but fixing the processes that create and maintain those forms and those attributes that we care about. One of the ways to get there is a low tech, a sort of lighter version of that, if you will, which relies on building simple hand-built structures. And one of the confusing things with this is people are used to, when we build something, we want it to last. We want to feel good about it as a monument of our, I don't know, building skills or our engineering, et cetera. And, when we say these things that you build, they are not the solution, that confuses folks. So some of the more popular things that are getting built, PALs and BDAs, there's a whole slew of other structure types. You don't always need posts. We have ALs too, but post-assisted log structures, these are just hand-built structures that mimic and promote the process of wood accumulation. Not just this pile of sticks we put there, but what else can be recruited and pile up and make this more complex. Beaver dam analogs, hand-built structures that mimic and promote the process of beaver dam activity. So yes, we'll have a even elevation crest, just like a beaver would. We'd pond water up behind it. But unless that's being maintained, expanded on, et cetera, by beaver, then we haven't necessarily done our job. Okay, and so when we talk about this, what's the P in process-based restoration? No, we're not just talking about a can of lager and just water. The process of this stuff, of the community building, this is fun. This is important for winning hearts and minds. But these actions, think of them like a meal. You're preparing a meal for friends for this system, and you're going to try to get it to take that nourishment and nurse itself back to health. So one of the places we can get lost on process-based restoration is basically the things that Emily and I teach classes on, right? So we can study hydrology and hydraulic processes, geomorphic processes, biologic processes. We can study fire ecology, et cetera, et cetera. All this stuff is fascinating, okay? But we can sort of lose the plot. And so when we are focused in low tech, we are focused on key processes, just like you would focus on a keystone species, so that you don't have to measure and watch the entire ecosystem. If that keystone species is doing okay, then you can probably infer, because of its dependencies on the rest of that ecosystem, that it's also doing okay. Similarly, I can focus on wood accumulation, and to get all this wood racking up, I've got to have a lot of those other things going on. I've got to be able to grow the trees in the first place. I've got to be able to recruit them, transport them, et cetera, et cetera. So when we say low-tech process-based restoration, it's not just a stolen logo. It is the processes of wood accumulation, beaver dam activity. You could throw fire in there. You could throw, rhizomatous root mats production. But these structures, these are just the low-tech sort of additions, temporary structures to try and kickstart those things. So we have 6 other principles, so 10 in total, 4 that tell us about what it is that constitutes a healthy riverscape, and 6 that kind of put our actions in context and give us some guides. It's okay to be messy. There's strength in numbers, use natural building materials, and defer decision-making to the system. I'm going to just, in the interest of getting us done on time here, I'm going to just, these are fairly obvious. We need big meals. We can take inspiration from beaver, use locally sourced natural building materials. For example, all the excess fuels that are on the landscape that we are harvesting for forest health and rangeland health to improve things, that byproduct is great as a building material. And having the humility to not make every single decision and let the system use its stream power to do work. And we actually heard Alexa talking about some of these things. This from Ben's article in Science is really the sort of take home on those, that our solution is not our silly little structures. The solution are the processes that we initially mimic, quickly promote, hopefully, but then get them to self-sustaining levels. So I'm going to bring this back to fire. And just like Lenya pointed out, fire is a key process too. And we saw those wonderful examples where beaver are there ahead of time. They can be, refugia, fire breaks, etc. But they aren't everywhere, okay? And so, most of the Sharps fire from where those photos you saw came from actually looked like this. The conditions were degraded for other reasons, and you didn't have big enough riparian areas to support the sort of beaver dam activity. I think that we need to stop focusing so much on fire, just like we heard Lenya point out, as this disaster and fear of the debris flows, etc. I mean, surely these things are a hazard if you have infrastructure in harm's way, but they're also a political opportunity. Convincing this person that their place is built in somewhere, that's stupid ahead of time before the fire is a pretty hard ask. After the fire, we can stubbornly rebuild in harm's way again, or we have an opportunity to think about whether or not we could relocate out of harm's way. There's also an opportunity in the very immediate aftermath of the fire where we expect big debris flows, we expect big elevated runoff, etc. And there's been a history of actions during those times to try to restore things, but people get worried because they build a structure, it blows out, or it gets buried in one of those debris flows, et cetera, et cetera. Well, we wanted to experiment with trying to use these structures to accelerate that recovery process, to short circuit it, you take advantage of this increased stream power. And so here was a little pilot, which was really governed by how much we could get done before it snowed. So, throw a bunch of sticks and stones in the creek and see if it can amplify some of those processes that Alexa talked to us about. The temptation is to use beaver dam analogs everywhere. The only place you should use beaver dam analogs in an emergency situation post-fire, in that first, few months or first season afterwards, is where some vegetation established that could support beaver. Otherwise, this is my most expensive structure to build at, somewhere between an hour and a half and 3 hours. Whereas I can build some really sloppy little, wood structures for 15 to 30 minutes and build a hell of a lot more of them and get the same sorts of responses in terms of widening and aggradation that we're after. And so in the manual, the low-tech manual, we have a bunch of examples of this. We encourage doing things that are blasphemous to some people, like, eroding a bank. But what we're doing here is picking up on that model that Alexa showed us and trying to amplify with that elevated stream power post-fire, those processes that are already taking place. We're amplifying the restoration opportunity. And if you do that, then beaver can come in even quicker than necessarily 5 years after, maybe the next season things are triggered. And so this is that critical principle of letting the system do the work for us, deferring some decision making to both the floods and to the beaver. And we've seen this work for restoring incised systems without fire. Alexa showed us it happening naturally, but we think we can nudge things along with a little elbow grease with some of these things. This is an example of one of those spots where we had a BDA that was placed next to some riparian vegetation that survived, promoting overbank flooding in the spring runoff the next seasons, and a head cut. Well, not all head cuts are bad. If a head cut is threatening your only channel in town and marching right up that's one thing. But when it's a result of return flow from overbank flooding, that's a good thing. Here's some other examples from in Nevada where Robin Wignall, she built a lot of BDAs. And all she said was, well, hey, it was so cool to see some of these things fail. Here's a bunch of texts that she sent the first runoff season after she built a bunch of these structures, just so excited that some of them blew out and caused the channel to widen and a bunch of them filled in. And she realized, yeah, I could have done them with a little less effort, but still was able to invoke some of these processes that we're talking about. So use those principles as sort of a communication and guidance tool to sort of think about how we can invest in this space of riverscapes as natural infrastructure. The manual and stuff are online, as well as free modules and workshops, and post-COVID we'll be spinning up the in-person workshops again. So with that, I'll leave the conclusions on the screen, end supposedly roughly on time, and we'll spill into questions here afterwards. Thank you so much.
Thank you so much, Joe, and thanks to Emily and Alexa as well. Those are really wonderful presentations. I feel like I've talked to all three of you about Beavers so many times over the last few years, and yet I learned something completely new every time I hear you speak. So I think we still have about we can maybe 10 to 15 minutes of questions, if that's okay with all of you. And I wanted to start with a quick question of my own, which is about policy. Now that we know how beavers and fire interact, what do we do with that information from a management standpoint? And by that I mean two things. I mean, first, of course, they're the animals themselves, which we do kind of trap with aggressive prejudice in some cases, and also the structures that Joe's talking about. Every state seems to have kind of a different permitting process when it comes to process-based restoration. So how can we cut through some of the green tape, as Michael Pollack has called it? What do we do about that? So any of you are free to take that question. But how should we be managing beavers now that we understand how important they are from a fire perspective?
We have to recognize that, what levels, state and federal, that some of these policies exist at. The management of beaver is something that is dealt with by all the state wildlife management agencies. And as Alexa hinted at, Washington has, different rules than, for example, California. California is in one of these weird situations where, unlike most of the time, they're way behind the times on recognizing beaver as native to much of the state, and so they don't allow translocation. But in most places, translocation is allowed. On the fire side specifically, maybe we could ask if she's already left. Oh, shoot. But on the fire side, I know that there's programs like emergency watershed protection and burned area emergency response, et cetera. And talking with some of the leadership in those groups, they're fine on moving forward. And there's some examples that are emerging of using low tech to do this post-fire work. So I think that's an area that needs to get a little bit more maturity. But just like the beaver restoration stuff, it can kind of fly under the radar, but then once it gets a critical mass, things need to move out of interpretation into explicit policy on these things. And to my knowledge, there hasn't really been anything at the federal level that's explicitly allowed. It's more just been interpretations on the fire side about letting us go with some of these things.
One of the challenges to address too is has become quite clear in our neck of the woods when it comes to putting structures into a system, whether those are woody natural structures or potentially surface water elevation control structures or beaver deceiver structures. There's now becoming the issue of fish passage and whether you can ensure fish passage in simplified human modified systems when you're also trying to manage for species recovery, habitat restoration, ecological benefit, natural processes. A lot of times there isn't room for natural process to exist in a site, yet we're still wanting to try to take advantage of every little square inch we can make of it, but the policy isn't there. We are kind of leading all of our state and federal agencies into this discussion now, and that's where we need to focus a lot of our efforts and building of understanding of how these things work, why there are steps in experimenting and evolving these strategies, and how we get to that long-term sustainability of a natural process, or as close as we can make it, with compromise and coexistence and complexity. We have to have different management tools in order to manage all those different types of complexity, whether it's human infrastructure or beaver salmon. I mean, there's so many different levels of interactions that are occurring. And so how do we make that allowable or understandable on a policy and a funding scale?
Great. Here's a question for Emily, this is from Victoria. Have folks actually measured impacts of beaver on animal communities pre and post fire? Right, they seem to be creating these refugia areas. How are wildlife using those refugia? And I guess more broadly, I'd be curious to know what are sort of the next directions for you as a researcher as you study these kinds of complexes.
I think you all saw the data today, which was that picture of a black bear. It's not well studied. It's challenging for a lot of reasons to do studies that are in situ in a fire, especially if you are looking at mega fires. I use remote sensing because I am one of these like big nerds that hangs out on the computer all the time, and I love it. But it's like you can't just go into a wildfire and like write down who's hunkered down in that wetland with you. That's very dangerous, and you don't necessarily know where these are going to start. And so to truly monitor this, you'd have to have an absolutely massive network of game cameras that you're comfortable saying, like, if these burn, they burn. And that's expensive. So the most data that I've seen is sort of in the pretty post state of the fire. So after it's sort of been put out and the processes start to happen again and animals can come back. It's tricky. So like photographs from the emergency response teams are the data on this right now. And that is an area of research that I am actively interested in and pursuing, is how can you quantify these species and what's actually hanging out here during the fire in maybe a less expensive way or more remote way, because I mean, even just getting drone permissions can be challenging in these places. So lots of work to be done. I think there's modeling work that you can do. I love models, but you know, my models are not going to be as compelling as like a photograph of a baby bobcat sitting in a beaver pond. So trying to find that right balance of quantitative assessment of who hunkers down there for how long versus how can you prove it and compel people that this is a real phenomenon we should care about. Kind of two questions that both still need answering.
I look forward to the answers. Here are two kind of related questions about reintroduction, which are first, where the science is unclear concerning past presence of beavers. Can you tell where they should be, or where they can be reintroduced? And second, what are the minimum thresholds of water flow, channel width, et cetera, required for a viable reintroduction, especially into semi-arid landscapes? So, I mean, this is a good spot, Joe, for you to talk about BRAT. And Alexa, maybe you could also bring up, what is the Metau Beaver Project's methodology for figuring out where to stick these animals?
Yeah, there's that's a good question, and kind of one of the things that was also in the chat was a question about what's the range of beaver in North America. Pretty much, or well, at least in the lower 48, pretty much everywhere is the easier thing. They could be far more places than we expect. We have a model that's called BRAT, Beaver Restoration Assessment Tool. And one of the things that it tries to do is predict where beavers will build dams. And because beavers can exist in a much broader range of landscapes than, there's a lot of places that are wet and have deep enough water to provide cover, but that they don't need to manipulate to make it suitable for them by building dams. And that part on the restoration side of them building dams is where we're interested. So there's good tools for sort of expectation management on that. And if we're willing to take some models that attempt to estimate pre-European disturbance sort of vegetation patterns, then we can also use that same logic to make an estimate of what it might have been historically. And that gap between historic and existing, sometimes we can close that down. But we just have to recognize what are the constraints, current land uses. Some things are modifiable, reversible, some things aren't. So yes, there's tools out there to kind of help with that expectation management.
And for relocating beavers when they do have to move from conflict, we have site assessment tools that we've developed over our time in really trying to understand what beavers need in order to be reestablished somewhere. And even when all of those things are represented, the boxes are checked on our forms, they don't always stay. But the things that we absolutely look for are deep enough water, 1 meter or more, for them to have cover from predators, vegetation cover as well, a little bit of complexity, and then vegetation itself in order to support a beaver or a family of beavers for at least a year to a year and a half, to give them a chance to build some dams and start holding some water. That was our whole intent to move them in the first place, was to improve the ecological benefit of storing water on the landscape. So we look for that 6 to 12 acres of riparian vegetation within a zone that provides deep water and cover for beavers. Ideally, and we're switching that, this is new for us, we're trying to establish those sites closer to their denser populations rather than way up in a headwater stream 8 miles upstream, where if they lose a mate, they are monogamous generally until they lose a mate, and then they go looking for one. If they have to go look for one, they're going to walk a long ways and likely get eaten or die in some other way before they get back to other beavers. So we're trying to work in this complex system with a lot of thought and different tools in our basket, as I described before.
That's interesting, Alexa. I didn't realize that sort of that methodological shift about where you're putting them in relation to existing colonies. That's an interesting idea, and
Yeah.
makes a lot of sense.
And we really are focusing on that low-tech restoration with structure, as Joe has brought into our understanding so well, to look at restoring places closer in on public land still. And in our state, WDFW, Washington Department of Fish and Wildlife, has a lot of state lands closer in to private land development. So that's been a really great partnership for us, is to start working on stream restoration with structure in order to accommodate greater beaver reestablishment in a more likely successful pattern.
And it's funny, Ben's last chapter of Eager has that story with Jay Wild, right, of building the BDAs to then get the beaver to stick. That's entirely inspired from the Methow project and from Alexa, your predecessor, Kent, telling us those criteria, which aren't met in a lot of places, right? You don't have a meter deep of water. It's like, well, and so we're like, oh, well, we can do that. And then we dump them in there, and then we give them a few choices upstream and downstream, because we expect them to be like our teenage kids and not listen at all and split. And yeah, that's that story that Ben does such a better job of telling. That's inspired by actually this boring form and insights from you guys.
Yeah, because there aren't too many places on the upper landscape that have, like Joe said, a meter deep of water. If it might be 3 feet wide, if it's a meter deep,
Yep.
That's about all you got. I'm working English and metric units. Sorry, everybody.
Great. Here's another question about beaver reestablishment. This is an interesting one from Garrett Altman. He said that so our tribe is working with a fire/debris flow affected watershed 10 years post fire. They're sort of focusing on low tech nature-based efforts. Beaver have been absent, but they're trying to reintroduce in the coming years. So what strategies can Garrett's tribe take to promote recolonization? Is it about BDAs? Is it about replanting? In that kind of scenario, what can you do to kind of lay the groundwork for reestablishment, either through reintroduction or sort of natural recolonization?
Yeah, I mean, it's kind of what Alexa does and talked about, and it's the BDAs, as long as you're kind of using in a place where you think if there's either beaver in the area and you're getting them to opportunistically take advantage of those, that's one thing. But if you're doing it for translocation, the only thing we haven't talked about in some of the previous answers so far that's a very common thing is also the grazing management. If you don't have a good handle on the grazing management, not all these places are grazed, but many of them are, then it's going to be really difficult to get that riparian reestablishment, which as Alexa was mentioning, making sure there's enough suitable vegetation around. Also the expectations, they move around a ton. And especially in more food limited and semi-arid places, they're moving all over the place. And so just having a big enough sort of footprint for where that's going to take place. And On the grazing, it doesn't mean that grazing is incompatible with beaver. It just means that, you know, it has to be proactive grazing, and thinking carefully about the timing, you know, when you move the animals around, so that you're not just, I mean, the combination of something like a beaver that likes this stuff, as well as a big heavier ungulate, yeah, that'll decimate a place. But there's ways you can effectively manage for that.
One of the coolest ways we're experimenting with to manage the livestock as we're trying to restore streams with process, structure, and beavers is in fires. There's a lot of standing dead wood a lot of the time, and it's starting to fall 10 years after fire. And oftentimes it's just over an incised channel, it's falling crossways and not interacting with the stream. So what we've started doing when that condition exists, and the landowner permits us to do so, we are going and pulling that structure into the stream and just starting to rebuild structure willy-nilly, pick up stick style, without a lot of effort. We did 800 meters in 2 days. You know, it was just really exciting in this one spot. And now there's beavers upstream who have the potential, well, there are beavers upstream from this site, and they have the potential to come down and start working as the water starts doing the work, widening that channel. The beavers can take advantage of even the smallest opportunity to build on that structure that exists in there. So the planting, the structure, the landowner acceptance or willingness, all of those go into play together. So you kind of have to come at it from every angle you can come at it from in order to try to support beavers in that environment better. And if you don't have any local beavers, there's certainly going to be conflict where there are beavers, and you can try to team up with folks who are working on that front to relocate them to the site once it can possibly support them. Otherwise, they're just going to leave and you've wasted your time.
Right. Great. So we've got time for a couple more quick ones. I think this is a good one for Emily from Lisa, which is, have you seen beavers have to move out of an area at some point after a fire, even though the complex survived the fire, right? So these are animals that, of course, you know, they need food and construction material. You know, what is sort of the long-term fate of some of these refugia sites?
They definitely move on sometimes. I mean, if you mostly destroy the surrounding habitat, if you had a full family of beavers there and they suddenly feel like that's not enough food, or if a bunch of ash starts going into their pond and they're not interested in dredging at all, they'll move. They'll look for better habitat. How successful that move is going to vary on how far away the better habitat is. If they're in the middle of a burn scar and they were the only beaver pond, that is probably not going to be a successful beaver story after the fire, even if the complex did initially make it through. These are large ecosystems with a lot of factors at play. But if you have strings and strings of these beaver complexes, then that movement is easier, and they can go back up and downstream and find portions of the riverscape that are in a better condition and sort of reestablish. Sometimes the complex is large enough that they just keep on trucking, like the one from the Mantor fire. That one has not changed occupancy, as far as I can tell, in a significant way over the last 25 years. But other ones, I mean, post-fire, or even during fire, sometimes the beavers don't make it. They're pretty awkward if they get caught in the fringes when the fire hits. That's not going to work out well for them. But the real important thing is that the more beaver complexes you have established, the more habitat is being preserved, and the higher the likelihood that a larger portion of that ecosystem can stay intact.
Great. Well, with that, I think, yeah, I think that we've basically reached our time. So I wanted to say thank you so much to Natural Heirs Association for putting this on, and to our three esteemed speakers for joining us. That was really fascinating and wonderful. And I'll let Moira close it out.
Well, thank you all so much. This was fascinating. I can tell from the comments, people really enjoyed it. And I apologize that we did not get to all your questions. However, Joe, Alexa, Emily, I'm sure Lenya, Ben are all would welcome your emails if you have further questions and would like to know more. It's a tremendous topic, and I know I learned a lot. So thank you so much. And if you want to know more or reach their bios, just go to www.naturalareas.org. So I wish you all a great day. Thanks so much again, and happy Earth Day.
Happy Earth Day. Thank you, everybody.
Bye-bye.